SwayamPrabha. Digital India. Educated India.
So, we are in lecture 4 of module 4, which is on concrete, and in my previous lectures we have seen how concrete is being cast, and then after that we had started to enter into each of the ingredients. The last lecture was on the two aggregates, that was the fine aggregate and then on the coarse aggregate. Now, today we are trying to cover the most important player, which is the binder, which binds all the substances, which is, or the ingredients, which is cement. It is the costliest within the mix and which is the minimum used in a mix almost and in most of the times, and yes, we will try to cover its manufacturing, composition, and then the main part, which is actually giving it the strength, the hydration of cement, the gel space ratio, setting of cement, then the heat of hydration and the different types of cement, which we will try to open you to. Mostly we use the ordinary Portland cement for our in general constructions and particularly in our atmospheric condition, that means the temperature and the humidity. Now, cement was found as long back and was named as magic powder. Why magic? Because it could set, it was an adhesive, it was being helping in binding of any kind of material. So, initially it was found and it was grey in color, and ordinary Portland cement was the name when it started manufacturing. So, we have two types of cements. One is the hydraulic cement, which sets in presence of water, which is the ordinary Portland cement. It is missing in the bracket, and other one is the non-hydraulic cement, which also we had discussed, which is lime and gypsum. So, which do not set in water, so it delays the process. Otherwise, the ordinary Portland cement, if we will come to the ingredients, then we will know that ordinary Portland cement, whenever it comes in contact with water, it sets. Even bags of cement which are purchased are to be kept and used within a short period of time, because to avoid setting, because it is a bag usually 50 kgs, and if it sets, it is a loss of the money, say around 400 rupees a bag, 380 rupees a bag it comes. So, we have to understand that if we expose cement, the hydraulic cement which we use regularly, it sets. So, let us come to each of the phenomena one by one, and first we try to know what is it made of. Unlike the other two, the sand and the, which is the fine aggregate, and the coarse aggregate, those were naturally occurring, but here it is man-made. And you see, again it is the list of the stones. The calcareous rocks having limestone, that is rich in calcium, agrilocalcareous rocks, which is again clay and limestone, argillaceous rocks, which is having alumina, that clay, iron ore, which helps in formation of the ferrites, and sand, which helps in formation of the silicates of the calcium, etc., which is present in the rocks. So, now again you see it is the same material from which we are making the usable material, which is the binder in the entire item of concrete. So, rocks are crushed and then heated in clean. It is a very basic line I have used, but these rocks come in various proportions, that is batching is required, and there is a dry process, there is a wet process. I am not elaborating much into it, but coming to the major part. When these dusts in their proportions are mixed, they are actually put into a system where you see the first part, it is the moderate temperature zone, then it is the average temperature zone, then it is the maximum temperature zone, which shows that the heat is sent from this direction. So, here is the burner and the temperature gradually moves from this end to that end, keeping this end as at the hottest part. This is the hottest part. You can see the temperature written over there. But the raw materials are being fed from this direction. So, the raw materials gradually move from this side to this side. So, here it receives some 800 degree centigrade temperature, and here actually the dehydration of the entire stone takes place. This area is the calcination zone, and the last part is the clinkering zone. Clinkers are small ball-like substances which are the transformation of all the dust, the mixed dust which had been fed into the system as raw material. So, the clay decomposes, the lime decomposes, as you see the sequence of actions here, the clay decomposes, the lime decomposes, some initial compounds are formed, that is the mixing of the items are happening, the calcium silicates are formed, the dicalcium silicates, the tricalcium silicates, the aluminoperites, the calcium aluminate, these compounds start forming, and you see these are finally formed. So, you see here is the clinkering zone, and it is the cooling, gradually it moves into the cooler and it is discharged. So, the clinkers are now ready for. So, what is this clinker? These clinkers are varying in size from say 0.5 centimeter to around 5 centimeter, small ball like substances, but these are kept aside. Why? We come to the next item, which is gypsum. Gypsum is nothing but a mineral sulfate, calcium sulfate, which has two molecules of water. So, this hydrated calcium sulfate is required to be added to the clinker. Now, this clinker, what has happened? This clinker needs grinding. This clinker needs to be dry and cold. So, those are preserved, those are cooled, and now you are grinding it. When you are grinding, you are adding this gypsum to it. So, clinkers, you see the diameter is written, they are cooled, clinkers are ground and they are mixed with gypsum when ordered. Ordered means ordered from the site, because once this powder is made, which is named as cement, which reaches the site, its life starts from then, and you cannot keep it on shelf for a longer period of time. So, the person or the manufacturer will lose the cement if it is not ordered and he is manufacturing continuously. So, the clinkers in cold condition are mixed with gypsum when the order is placed and it is bagged in form of cement. Now, if it were mixed when clinkers were hot, what would have happened? The hydrated gypsum, the two molecules of water in gypsum would become anhydrous, it would have evaporated, because this gypsum coats the cement particles and delay the setting process. So, we will come to setting later, but setting in brief or in one word is the binding. Usually 2 to 5%, 3 to 5% maximum gypsum is added. If you keep on increasing the amount of gypsum, the setting will be much delayed. So, we have to also keep an eye that adding gypsum would not help in more. So, the role of gypsum is to adjust the setting time. So, if you require a quick setting, say you need a construction to be usable or to be allowed to move, say vehicular movement very quickly, or it is an underwater item being cast, or it is a foundation in a very marshy land, you need quick setting. So, what will you withdraw? Gypsum percentage you will withdraw. How can you take it out? No. When you are ordering, you have to order for a quick setting cement. So, if you add more of gypsum, it will delay setting. If you withdraw gypsum, it will make flash setting or quick setting. Now, coming to the composition of cement, of which one is gypsum, you have all known, but what are the other formation of those stones which you have added? They have formed finally tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. Now, here you see it is 3CaOSiO2 and it is abbreviated as C3S. So, this indicates tricalcium silicate. This is dicalcium silicate and the abbreviation is C2S. If you see tricalcium aluminate, you see C3A, and you see tetracalcium aluminoferrite, it is CaOAl2O3 and Fe2O3. So, it gives C4AF. Now, here you see there is a ferrite, and finally, it is gypsum which is added at the last and its percentage varies, and gypsum is also abbreviated as it is sulphate, calcium sulphate, S bar, and H2 implies 2 molecules of water. So, whenever we talk of cement, whenever we say C3S, it is tricalcium silicate, C2S is dicalcium silicate, tricalcium aluminate is C3A and the other two. So, you do not have to remember all the formula, but it is the basic way of remembering. Why we need to remember? Because all these items react in different times to have or help in the setting process. So, that brings to the hydration of cement. When water is added to this cement, actually all the ingredients which we had talked earlier starts their reaction with water, and it is a surface reaction. So, you see carbon hydrogen, it is actually calcium, it is the calcium and H is the water, calcium oxide and the water. So, these hydrates are forming, and gradually this hydration keeps on forming with time. It is a function of time and not always all are reacting. Who is reacting first? The tricalcium sulphate is reacting first, and it also liberates heat. So, we will come to the heat liberation part also, but now presently we are looking into the hydration process. Together water and the cement forms a slurry which is called the gel. These gels are not, gel is nothing but submicroscopic crystals of calcium hydroxide, C-H. C was calcium oxide and H was water. So, they combined and formed calcium hydroxides. You get a lot of series of hydration reactions, and collectively this hydration, it is called hydration, and they have high surface area. Why you need this surface area? Because if you remember the sand particles, all the sand particles are surrounded by this cement gel. And if you remember, during sand we discussed clay. If there was clay in the sand, then that sand would be, the clay would have not allowed this gel to reach the sand particle. So, this high surface area, the gel actually coats the sand which sits on the top of the coarse aggregate, and finally that binds. So, individual components react at different rates, and finally cement achieves the strength, and all other ingredients along with it gets bound. C3S, that is tricalcium silicate. This hydrates and hardens rapidly, and it is responsible for the initial strength in the first week of concrete casting. If you remember the curing of concrete, which was discussed in the first lecture, we have to cure concrete for 28 days. So, this hydration process of cement of this particular C3S, it is a very initial phenomena, it is a surface phenomena, it gives the initial strength to the concrete mass. C2S, dicalcium silicate, it hydrates and hardens slowly, and it is responsible for the strength beyond the first week. It is the strength of the concrete. Though the reaction of cement starts with its neighboring items, that is sand or coarse aggregate, but the strength of the entire mass builds up after first week due to dicalcium silicate. C3A, that is tricalcium aluminate. This hardens rapidly similar to C3A and leads to stiffening of the item. So, item becomes stiff because you cannot de-shape it. Gypsum retards the hydration process and thus delays the setting of C3A and also of C3S. So, that is the major role of gypsum in cement. C4AF, that is tetracalcium aluminoferrite, hydrates rapidly but imparts no strength to cement. It is important to bring down the clean temperature when the cement formation was happening. If you remember the clean temperature, as I told, 800, then 1000, then up to 1500, it would not have happened in 1500 if there was no tetracalcium aluminoferrite. So, it brought down the temperature of clinkering while in the manufacturing of cement, and this actually is giving or imparting color to cement. And if you can, if we are precise, it is the ferrite which is giving the color. Now we come to as we have talked of this gel, we come to how it looks. When water is added to cement, it is here you see a picture where you can see that lots of gaps are there. It is the gel matrix, and these gaps are called the pores. These are the spaces in between, which is actually in cement mix, it is or in the gel it is the void or the gaps. So, gel space ratio, as you can see, it is the ratio of the volume of the hydrated cement paste. So, what is the actual volume? Divided by the sum of the volume of the hydrated cement paste and the capillary pores. So, if you add up all these capillary pores with the volume, what you see actually is what is the denominator, but on the top it is actually what volume you have added and you are supposed to get, but because of these pores it has increased in volume. So, the gel space ratio, the spaces actually are the pores or the voids. So, lesser will be the void, higher will be the strength. So, the intrinsic strength of the gel depends on the gel space ratio. So, this water and the cement together that forms the gel leaves pores inside, and these pores, if they are more, the strength of the cement will be less. So, here you can see the graph, and here is the compressive strength in Newton per millimeter square. It starts from with a gel space ratio, it is a decent amount from gel space ratio of 6 when it is 40 Newton per millimeter square, and with high it goes higher when you end up with minimum of capillary pores. Now, coming to the how to know the setting time. As we had talked, the setting of cement, like how it hardens, and we have talked that C3S is important for the initial setting. So, setting time actually gives an indication of how much of hydration has happened, whether it is undergoing normal hydration, whether it has enough of water, and usually this setting time is split into two. As we talked, C3S and C3A are mostly responsible for the initial setting. That is, their reactions or hydrations happen faster and in the very beginning, and gradually it pulls, the time increases and the hydration still continues, and that is why during curing you always need to keep water. Yes, the water is mixed inside it, but that gradually the strength gain happens. So, depending factors are how fine the cement is, how is the water cement ratio, we will come to that little later in the next lecture. What are the components and their proportions, what are the kinds of plasticizers and admixtures added, we will also elaborate on that, and what is the gypsum content, because gypsum retards the initial setting. We have the Vickers test, where actually a plunger is allowed, a plunger with a given tip dimension is allowed to fall on a cement mix. Here it is a mix of cement and water, and this plunger drops into it. So, when it is initial set, it will penetrate and it will be almost 5 to 7 centimeters left, 5 to 7 millimeters left to enter. So, it can penetrate because after initial setting it has not hardened totally. It is allowing this plunger of 1 millimeter square base, that is the bottom is like this, and it enters into it. Now, this plunger is held by a support, and that is called the Vickers test. There are images, but as those are not free images, I did not use it here. You can always check it if you can access internet. Now, this plunger, if we are going for testing again after some time, this plunger won't get inside so much, it will just stick and stop here. If it has finally set, it will just make a mark if it is 1 millimeter square plunger, that is the base is 1 millimeter square in dimension, and if it is a 5 millimeter square dimension, it will not even make a mark. That means the cement has undergone final setting. So, here is the initial setting. It is written, it should be done after around 30, within 15 to 30 minutes, and here is the final setting where the hardening has happened and the cement can take the load. It is 1 millimeter square plunger making an impression and 5 millimeter does not. 5 millimeter square plunger does not. It is to be done around after 6 hours. So, this is how you can understand the setting of cement. Let us come to the heat evolution process. Per gram of cement evolves 120 calories of heat. It is not a matter of joke. 1 gram of cement liberating 120 calories of heat, and if you see the graph here, in the initial setting process, that is, you see stage 1, within the first half an hour, 15 minutes to half an hour, because of addition of gypsum, it is delayed, otherwise that time would have been further reduced. You see the graph has gone high as a comparative you can make out, and in stage 2 it is dormant. This entire period is under initial setting. During this time actually the C3S and C3A are getting hydrated. Others have initially initiated the process of hydration, and you can see again the graph rises up, but it is a gradual process, some 12 hours to 20 hours this stage 3 and gradually coming down, this hydration decelerates. So, in these two time periods, during this time, this amount of heat is liberated, and if this heat is not gradually taken out, it may lead to finer cracks inside. So, these points are to be remembered. Hence, concrete, whenever it is done, it is kept moist and also in contact with air, and it gradually cools down. That helps. This gradual process of this heat being liberated is also to be controlled so that you do not end up in cracks. So, this is the heat of hydration. What you need to know is the process of initial setting and the process of final setting, and this hydration process which is happening very gradually, and that actually gives you the final strength. Now, coming to the types of cement, to close with, it is mostly we use ordinary Portland cement. We see it has 3 grades, as we had seen fineness modulus. Here also this can be done by help of a turbidimeter, and we have grade 53, grade 43, grade 33. The dimensions are given and the IS codes are also specified. Any item is to be incorporated in code that I think initially given a feel of. So, hydration process is proportional to the surface area. So, finer the cement, more the number of particles and faster is the hydration. This I had discussed when we touched sand. So, finer particles bulked more. So, that was because that was in contact of water more and bulking was more. Here it is the hydration process is faster. So, fineness is measured by in a turbidimeter. In a turbidimeter, I is missing, there is an I here, turbidimeter, and you are actually measuring this. Here is a list of other different types of cement. You see, I will read it out for you. Rapid hardening cement means it will set quickly. So, higher will be the amount of C3A and lower will be the proportion of dicalcium silicate. Similarly, quick setting cement will have less of gypsum or maybe no gypsum. So, it will set very quickly. Low heat cement, it means it will have less of C3A. That means the first part or the initial setting time where the heat liberation was maximum in a very short duration of time, it will have low heat will be generated. So, it is low heat cement. Sulfate resistant cement, it is C3A should be below 6%. Super sulfated cement, that is slag and gypsum and clinkers all together almost equal in amount. Blast furnace cement or slag cement, which is 40% clinkers and 60% slag from iron industry. High alumina cement, which will have high percentage of C3A, automatically the other percentages will change. White cement will have no iron oxides, that is the aluminoferrite would be missing because iron was imparting color, and you will not get any color, specific color of cement, and you will get white cement, and this is a very costly item. This is available in kgs, that is in bags in 1 kg, 2 kg per amount, not in 50 kgs, and these are used mostly for finish purposes. Pozzolanic cement, it is a volcanic rock powder from there, and air entraining cement, when sodium sulfates, glues, resins added, it forms air bubble within it, and that gives it a lesser volume, lesser density, porous, insulating capacities. So, with all these we conclude that cement is a man-made thing from stones. Gypsum has a vital role in playing the setting time of cement. Cement forms the binder and hydration is necessary for it. Initial setting is followed by final setting, and by changing the composition of the different constituents, you may get different types of cements. Codes are to be followed whenever we are dealing with any kind of cement or cement in a concrete mix. Cement as itself can be used, the slurry can be used as a finish material on top of floors, which we call usually as the Indian patent stone. Many floors where there is no finishing, a cement slurry is given, and it creates a very thin 5 to 6 millimeter layer, and it gives a very neat cement finish. Otherwise, it is used with sand as a mortar or in concrete as a mass or a composite, where cement plays as a binder. So, we end today's lecture here.